Okay, so we've been talking about angles, and we've been talking about angles on a point. Do you remember that last time? Angles on a point can make a complete circle. All right, make a complete circle, which means they add up to how many degrees? 360. So if you know some of them, you can find the missing ones by simply subtracting from 360, or you can say if they make a straight line, they add up to make 180. What if it's a right angle? They add up to make 90, right? So we looked at those last time. So what we're going to do today is we're going to continue doing that same kind of idea, all right? And we're going to talk a little bit about what are called angle pairs, and we're going to look at what happens with some intersections, and there'll be some other phrases as we go. Now, your job is to memorize a few of these words, and I'm going to show you those. You don't have to memorize them all. There are just too many of them right now. But as you move forward, we're going to build a little more in year 9. We're going to have and a lot more in year 10. Year 10 is really heavy on geometry. Okay? So there'll be a lot of it in year 10. So we're going to build it as we go. But today we're going to talk about something that if the adding up all those angles made sense to you, then this is going to be a piece of cake. But we're going to give them names, but the names make perfect sense when you think of these words. All right? So let's go. So what we're going to do is, first of all, I need to remind you of what intersection means. What does it mean when you have an intersection?
Does it look like the two lines come?
Exactly. So it's just like when two lines cross. Okay? Right? When two lines cross. Let me redraw that. I'm going to draw it a little neater and now I'm going to draw it neater just so that I can write on it, but it can be any intersection. They don't have to cross like this. They can cross any way. And there are two really important ideas for when these cross. So draw this big enough because we're going to write on it a little bit. Okay? And the first thing we're going to talk about are opposite angles. Now, we're used to thinking of opposite as meaning different, but when you're talking about opposite angles are always equal. Okay? And we're going to talk a little bit about it. We're not going to prove it or anything, but so opposite angles are always equal. So, for example, now, I'm going to have O, and I'm going to put a little 1 at the bottom of it. That just means the first opposite. It doesn't make any difference. It's just so that I can tell one O from another O. Okay? And so, opposite means you go across the angle. So, does that mean I'm going here? Here? Nope. I'm going here. So, we'll call that O2. And again, those numbers don't mean a darn thing. It's just that it gives them a different name so you know which one's which. Okay? So they don't mean anything. They have no meaning at all. It's just tell you which one's which. So those two things are opposites. Therefore, O1 is equal to O2. And if you think about angles, these are cutting across at the same angle because the top and bottom are going to be the same angle across. You're cutting across a straight line, right? So they have to be the same. There's no way they can be different. Does that make sense? Now, we also have another pair of opposites. We could call this one O3 and this one O4. And so what do I know about those two if they're opposites? They're the same. Okay? Does that make sense? Now, we also want to talk about what are called adjacent angles. Now, you've probably heard this word before. It's not one that we use too much in everyday language. But adjacent. Does anybody remember what adjacent means? Next to. Exactly. So side by side or right next to. And we think of adjacent angles the same way. So let's just say we draw the same one. Who cares? So if I have this angle, A1, this A2 would be its adjacent angle, side by side. Okay? So opposites are always equal, and the opposite means always across from each other. Adjacent means side by side. And if two angles are adjacent, that means they lie on a straight line. And what does that mean if I have two angles that lie on a straight line? They'll always add to 180. Exactly. So the sum is always 180. So if you know one of them, I can find the other one simply by subtracting it from 180. Right? We did a lot of that last time when we looked at those straight angles. Do you have a question? Yeah. Okay. Mm-hmm. Yes, exactly. So they're supplements of each other, supplementary. Good job. Thank you. We'll go ahead and put that word in there then. Right? Supplementary means they add to make 180. Excellent. Thank you for that one. All right. Now, so adjacent and opposite are going to be some really key things that you need to remember. So, and the reason why I'm focusing a lot on the names of them is you're going to be asked questions where it says, find the opposite adjacent to angle B. Right? And so you're going to need to know that means the one right next to it. The one right next to it on the straight line. Right? It's supplement, in other words. Okay? Then you're going to find another question that's going to say, find the measure of the angle opposite to angle A. Well, what do you know about opposite angles? They're always, well, they're opposite each other, but they're always what? Their measurements are always equal. Mm-hmm. Okay? So if angle A is 102, then so the angle opposite is also 102. Right? So if you have one angle at an intersection like this, then you can find all the others. Okay? And that's what we're going to be working with. Now, we're going to be looking at several different types of intersections, and so we need to be prepared to talk about the lines. Okay? So you can have a line that's doing this and a line that's doing this. Are those parallel? No. And then they could be cut like this. This thing that's cutting it is called a transversal. So you'll often see that word transversal. If a transversal cuts two lines at points whatever. Okay? Transversal is just the line that's cutting across. Now, since these two lines are not parallel, this set of angles and this set of angles will not be the same. They're cutting at different angles, aren't they? Okay? So we can't assume that what's happening up here is the same as what's happening down there. So we have to have more measurements. We'd have to have at least a measurement up here and a measurement down there to find all four angles. But if I did, it's no big deal. So let's say that this angle, looks like it's about 35 degrees there. All right? So if that's 35 degrees, I automatically know one of the others right away. How? The opposites. The opposites are the easiest one. The angle opposite it also has to be 35 degrees, right? Automatically. Now, I have to do a little math to find the others, but if you think about it, this is a straight line. So from this measure to this measure is a straight angle, which means it has to add up to 180. So I'll simply take 180 degrees minus the 35 degrees I have, which gives me what? 145? Okay, which makes this 145 degrees, which is nice. Why? Because that means that this is 145 degrees, right? We love opposites, right? Because all you have to do is rewrite the same thing. So once you find one, you can find the other. Right? So I just found all four angles for that transversal at that intersection. Yeah? Okay. So let's say that this angle was 150 degrees. This angle right here in the corner. If that's 150, what's the easiest one to find? It's opposite, so that opposite is also going to be what? 150. And now I have to find these two other angles. What are they called? Adjacent. And so I find those by doing what? 180 minus the 150, which gives me 30 degrees. So they are both 30 degrees. There you go. Okay? Yeah. It's not confused. It's just you just have to practice, right? Anything new, you just have to practice. Okay? Now, you want me to make your life even easier? Yeah? Look at this. We also have what happens when we have, now I'm trying to be very precise here, when we have lines that look like this with a little arrow in the middle, which means they are what? Parallel. Yeah, there you go. Parallel. Okay? Now, if we have a transversal cutting two parallel lines, it gets even easier. Because if these two lines are parallel, this set of angles and this set of angles are the same. They have to be, because the lines are parallel. They have to be meeting at the same angle, right? Okay? So if this is 140, for example, then what do you know about the opposite? 140. And what do you know about this one? And this one. And what do you know about this one? It adds up to make 180, so it has to be 40, which means this has to be 40, and this has to be 40, and this has to be 40. Nice, yeah? Okay, well, I picked a number that I could do the math. Okay? Now, so we love it when they're parallel because we don't have to worry about two different sets. They're always going to be, the angles here at the top are going to be identical to the angles at the bottom. Now, there are names for these, and the book goes through all those names for those. You are not being responsible for all those names. Adjacent interiors, yeah, not yet anyway. Not in year 8. Not in year 8. Now, in year 9, and especially, and in year 10, you absolutely must know the names of them. Okay? Yeah, it's going to be fun. Yes, ma'am.
On the test, will they, do we have to measure the angle?
Yes.
How do you measure the angle?
How does one measure an angle?
A protractor.
With a protractor.
How do you do that? I forgot how to do it.
Oh. You put the little dot of or the hole in the protractor right there with the baseline lining up against one of those lines, and then you just measure the other line.
Oh, that thingy thing.
Yeah, the round thing. Yeah. You put the flat part of the round thing there, and then there you go. Yes, you will be required to measure some angles. Shh. Tone down the chaos. Come on. All right. Here we go. Now, okay? So what we're going to do is we're going to go to the book and we're going to look at some of these. And again, they're going to get a little carried away with vocabulary. They're going to use a lot more vocabulary than we're worried about. What we're really worried about is opposite. Shh. What we're worried about is opposite and adjacent. Those terms you must know, okay? Because it'll say find the opposite angle, find the adjacent angle. So you've got to make sure you know which one you're looking for. So we're going to go to our textbook real quickly. We'll do some of these together. Okay. Here they're just talking about parallel and intersecting lines. And here they're talking about opposite angles being equal, etc. Remember the notation when they say angle. Now there are two notations for angle. You can do, so like they do COB and they put the little angle symbol above. You can also put it in front. Either one of those, they mean exactly the same thing. But the vertex of any angle, the name of any angle has to go where? In the middle. Good. Okay? All right, and here they're just talking about two straight lines intersect. Vertically opposite angles are equal in size. Right? So here we have A and C are opposites, yes? So A and C therefore are what? The same. They're equal. Good. Okay? Now here's where they're talking about all of these little different names. We're not so worried about corresponding, alternate, and co-interior angles. I'm not worried about you knowing all those names, but you do need to recognize that black dot, its opposite is down here. And what if I was looking for that angle? What would it be? Not opposite, but adjacent. Okay? So they're going to use these terms. You're just going to have to pay attention to where they are and deal with it. Okay? Right? So, guys, let's do it together. All right, so here, in each diagram, list the pairs of vertically opposite angles. So what's opposite of B? D. What's opposite of A? C. Okay, rocket science, boy, I'm telling you. Okay, in which diagrams are S and T alternate angles? Don't worry about it. Which angle? Alternates, I'm not going to worry about that. We're not going to worry about corresponding. Again, you don't have to know those. Co-interior, you don't have to know those yet. Nah. Here we go. Finding values. This is where we're going. Okay. What we want you to find all of the values of these. Why is this one super easy? Parallel lines are always the same. So if that top angle is 124, what does that make X? 124. Okay? Now they get funny on you here, but that's okay. If these two are parallel, where's your transversal? Okay? Shh. All right. Now, they give you lots of lines. These are your parallel lines. This is your transversal. So you are not worried about that line at all. They can give you more lines than you need. You find the two that are parallel and find out which line is cutting them, and it'll give you the information you need. So if this is 62 degrees, what else is 62 degrees? So this is, which makes this 62 as well, right? So just extend the lines so that they look like the others, right? That's not going to hurt. And then make sure you ignore any lines that you don't need to use. Okay? So don't worry that there are too many lines. Yes, ma'am.
Numbers for the exercises that are in like the challenge questions they have a little bit more than just...
You got to think. Okay. Cool. I didn't know they were color-coded. There you go. All right. So you can extend the lines. Now, look at this one. So these two, 15 degrees. So that means that's 15 degrees because these lines are what? All right. So here we go. Find them in unknowns in alphabetical order. Give reasons. So if you're finding A corresponds to 117. So that means it is also 117. And you need to describe why. Okay? Right. All right. So there we go. So this is where our homework is going to come from. Are they all parallel? Oh, they're all parallel. Oh, well. But that's all right. So exercise 2E. Guys, you're going to do exercise 2E. It's on page 51. All right, etc. And yes, you do all of them.